here's what we know. We know the left hand is down, and we know the right hand is down. And because, I guess really the left hand is the same as the right hand. Okay. So right away, what does that tell us? If the left hand and the right hand are both the same, even exponent. Even exponent. And if the right hand is down, what do we know about the lead coefficient? It's negative. Yep. Okay, now let's do the following. Let's write down the roots and the multiplicities. So for this point, what's the root or the x-intercept? -3. And then the polynomial goes straight through the axis, so what's the multiplicity? 1. Okay. What is the root for this x-intercept? 0. And it changes curvature, so what's the multiplicity? 3. This root, or x-intercept, is 5. And it touches, or bounces off the x-axis, so its multiplicity is 2. So, with this information, let's write the equation. Y equals, right hand down, negative. There are 3 x-intercepts, so we're going to have 3 linear binomials. The first one is right here. The root is -3, so we do the opposite sign. The multiplicity is 1, so the exponent is 1. The next root is 0, so we could write x minus 0. The multiplicity is 3, so that's the exponent.
I have a question.
Yes?
How do you know it's 3?
Because of the change in curvature tells you that it's 3. So here, we'll do a little okay, imagine that's the x-intercept. If the polynomial goes straight through, it's multiplicity 1. If it does this or this, it's multiplicity 2. If it does this or this, it's multiplicity 3. Okay? So, at 0, it does the change in curvature, so it's 3. The last root is at 5, so opposite sign, and the multiplicity is 2. Okay? What's that? It just is. You know how pi is 3.14159? It just is. It's just the way it is. Oh, what's E? 2.718. That's as far as I can go. And it doesn't need to be any further than anyway. Hey, I'm going to simplify this a little bit. Y equals negative. See this x minus 0? Can't we just write that x cubed? And I'm going to put that in front. And then this x plus 3, do we really need to write that number 1? No. And then x minus 5 squared. Okay. Now, this is where it gets ugly. Because if we wanted take the factored form and put it into standard form, we have to multiply it all out. So we'll just do one of these. But you should be prepared that maybe you would have to do this sometime. Okay. Well, let's rewrite this. I'm not going to put the y equals. I'm just going to write negative x cubed, x plus 3, and then we have 2 x minus 5s. I propose we start on the right and multiply these two together first. Bless you. X squared minus 5x minus 5x plus 25. Now we can simplify like terms, which are the x terms, so minus 10x plus 25. Okay so far? Now I propose that we just ignore this negative x cubed and we multiply the linear binomial times the quadratic trinomial. And the way to do that is to start with the x, multiply the x, distribute it to each of these three terms. So x times x squared, x cubed. X times negative 10x, negative 10x squared. X times 25 plus 25x. Now distribute the 3 to each of the three terms. So we'd get plus 3x squared minus 30x plus 75. Now let's combine like terms. We have an x cubed. Let's see, how about that x squareds? Minus 10 plus 3 is minus 7x squared. Combine the x's. 25 minus 30 is minus 5x. And then we have the 75. And lastly, distribute the negative x cubed. So y equals negative x to the 6th plus 7x to the 5th plus 5x to the 4th minus 75x cubed. That's a horrible process. What's that? Hey, now remember we said at the beginning that if the right hand and the left hand are down, it has to be an even degree. Yeah. Well, the standard form tells us even degree. Okay? But if you don't want to multiply that whole thing out, how can you tell just by looking at the factored form? I'll give you a hint. What do the multiplicities add up to? 6. Because you have x1 times x3, which is x4, times x2, which is x6. Okay. So that's always a quick check that you can do.